to the top of page 38 and locate part D of the previous question. We have one more piece to do of this question before we move on to the next part of the problem. We want to write the coordinates for the location of the buttons. In order to do this, we need to go back and look at the coordinate plane and ask ourselves, how can we find exactly the middle between the swings and the merry-go-round? Let's take a look. If we start out at the swings and we try to get towards the merry-go-round, we're going down and to the right. If we go down halfway and we go to the right halfway, then the point that we will arrive at is exactly halfway in between the swings and the merry-go-round. So let's go down halfway and go down halfway to the right and see what point we end up at. Let's start at the swings. Follow along with me. We're starting out at 312. We're going to go down to the midpoint at the kazoos. Now we're at 37. Now we're going to go to the right halfway. This is on the same line as the, what did we put there? Beads. We put the beads here. So we're going to go halfway to the right here. Okay? We're on the same vertical line as the beads. This exact point right here is where we would place the buttons. What point is this located at? Everybody shout it out now. If you shouted out 7, 7, you are correct. Okay, let's go back and answer the question. The coordinates for the locations of the buttons would be at 7, 7. The buttons are located at 7, 7. Graph the location of the buttons on the coordinate plane. See graph. Congratulations, you just finished part D. You found the location of the buttons. Now, let's move on and let's figure out how could we do this if those points for the swings, the merry-go-round, and the slide were somewhere else on the coordinate plane. Is there a faster way to do this? Let's find out. Take a look at the paragraph below. Read it aloud, following along with me. We'll start at the word suppose. 1, 2, 3. Suppose the slide, the swings, and the merry-go-round were at different locations, but oriented in a similar manner. You can generalize their locations by using x1, x2, y1, and y2, and then solve for the distances between each using variables. Okay, let's take a minute and figure out what did that paragraph say. Take a moment to think to yourself, what is this paragraph telling me? Okay, if you thought something like, I can take the swings, the slide, and the merry-go-round, and I can translate them, I can move them to anywhere on the coordinate plane, and I will know that a couple things are true. I will know that wherever the swings are, they're going to be the same distance away as how far the slide is on the x-axis from 0. And however high up the slide is, we'll do this one in blue, however high up the slide is, it's going to be the same height away from the x-axis as the merry-go-round is. So the merry-go-round and the slide are the same distance here on the y-axis as the slide and the swings are on the x-axis. Also, the merry-go-round is going to be on a different x location from the slide, so we can take the merry-go-round's location as x2 and we can take the swing's vertical location as y2. Okay, so far so good. Now let's use our vertical distance formula. We want to find how far is it from the x-axis to the slide. That's the distance from 0, 0 to the slide, which is at y1. Remember, our vertical distance formula is y2 minus y1, and then the absolute value. So take a minute to figure out how far is it from 0, 0 to y1. Okay, if you used vertical distance formula and you calculated that y1 minus 0 absolute value is equal to y1, you are correct. This distance from 0 to y1 is equal to y1. So far, so good. Now let's calculate the distance from the slide to the swings. We want to calculate this distance. Use the vertical distance formula. If you said that the distance from the slide to the swings is equal to y2 minus y1 absolute value, and then found it as y2 minus y1, you are correct. You can also imagine this as saying, what if the swings were at 12 and the slide was at 2? It would just be 12 minus 2. But in this case, we're using y2 minus y1. Now we want to find half the distance from the slide to the swings. So if the distance from the slide to the swings is equal to y2 minus y1, then we want to take half that distance. So half we'll write down as 1/2, and then we'll write down the distance from the slide to the swings as y2 minus y1. And the way that we're going to write this is we're going to write it as y2 minus y1 divided by 2, like a fraction. Good. So far, so good. Now let's do part D. We want the vertical distance from the x-axis to the slide, which we calculated here as y1, plus half the distance from the slide to the swings. So let's convert these words into the numbers. The vertical distance from the x-axis to the slide is this answer up here, y1. Then we have plus. Then we have half the distance from the slide to the swings. That's the answer here in part C. y2 minus y1 divided by 2. If you got this answer, you are correct. Great job. You just finished page 38.